Hello, my name is Brittany Newton, and I will be giving a presentation on the association between sugar-sweetened beverage consumption and the body mass index. So to give a little background, we'll be talking about the Behavioral Risk Factor Surveillance System, BRIS, of 2016. The objective of BRIS was to collect state-specific data on health risk behaviors, chronic conditions, and access and use of preventative health services, which is related to death and disability in the United States. This analysis is restricted to New York residents only. And so for this analysis, we'll be seeing the association between sugar-sweetened beverages and in the BMI. So for New York, the percentage of adults who were obese in 2016 was 25.5%. And the percentage of adults who drank at least one soda or another type of sugar-sweetened beverage was 23.2%. So the methods used for this analysis, data was collected by the researchers conducting landline and cellular telephone-based surveys. The data from these surveys were self-reported. The variables used in the analysis of New York residents included outcome variables, exposure variables, and covariance. The outcome variable was BMI, which was continuous. The exposure variable was sugar-sweetened beverages per week, and the sugar-sweetened beverage per week was a categorical variable for with 4 different groups, such as 0 drinks per week, less than 1 drink per week, between 1 and 7 drinks per week, and more than 7 drinks per week. The covariants or potential confounders are sex, age, ethnicity, race, education, income, physical activity, history of cardiovascular disease, and history of diabetes. The variable sex was a binary variable with 2 groups, male and female. Age was a continuous variable with anyone over the age of 80 being recorded to 80. Ethnicity was a binary variable with 2 groups, yes and no for being Hispanic. Race was a categorical variable with 3 groups, white, black, and other. Education was a categorical variable with 3 levels, high school graduate or less, some college, or college graduate. Income was a categorical variable with 3 levels, less than 25,000, between 25,000 and 50,000, and greater than 50,000. Physical activity was a binary variable with 2 groups, yes, experienced physical activity and have not experienced physical activity. For history of cardiovascular disease, it was a binary variable with yes or no. And ever been told they had diabetes was a binary variable, having been told yes or no. The variables were analyzed using complex survey weights. Stata statistical software was used to analyze the data. With the help from Stata, the data was cleaned, and after cleaning the process, descriptive statistics were developed for the combined sample and weight status. To examine the association of sugar-sweetened beverages consumption with BMI, simple and multilinear regression models were generated. Complex survey weighing variable was used to create crude and adjusted regression models for before and after adjusting for the covariance. To regress the outcome variable on the sugar-sweetened beverage consumption, the crude regression was ran with the survey weighing applied. To regress the outcome variable on sugar-sweetened beverage consumption, along with the other covariance, an adjusted regression with survey weighing was ran. The point adjustments or beta coefficients, confidence intervals, and p-variables were obtained from the software. The data was checked by examining CPR plots, residual plots, and Q plots. From the assumption set, no validations were found. So for the results, we have Table 1. Table 1 displays the descriptive statistics. When examining the results from Table 1, one can see that obese participants drank more sugar-sweetened beverages per week for the category of more than 7 drinks per week. Table 1 shows that there are a higher percentage of males that are overweight than obese or have normal BMI. The average age for overweight and obese was the same, but 5 years younger for a normal BMI. There are more Hispanics that are obese. Additionally, there is a higher percentage of whites for normal BMI, overweight, and obese. When examining education, the more education one has, the less likely one is to be obese. Less education, like education, income may be associated with BMI. There was a higher percentage of participants whose income was greater than 50,000 with a normal BMI. However, there are more participants with a normal BMI who had physical activity in the past month. Obese participants had a higher percentage of having a history of cardiovascular disease and diabetes. Also in our results, we developed Table 2. And Table 2 displays the results of simple and multilinear regression. From Table 2, one can examine the regression results. The primary research question related to the association of sugar-sweetened beverages consumption with BMI was determined from the crude and adjusted models. When examining the results from the crude regression, there is not any data for the covariance. There is only data for the sugar-sweetened beverage consumption. From examining the data, the only group under sugar-sweetened beverages consumption was statistically significant is the sugar-sweetened beverage consumption for more than 7 drinks per week. Since the more than 7 drinks per week is statistically significant, researchers are 95% confident that the percentage of participants that consume more than 7 drinks per week is between 5% and 81%. Moreover, the interpretation is that for every 1 drink increase in the sugar-sweetened beverage consumption, the BMI of the participant may increase by 0.43 units. Secondly, the association between sugar-sweetened beverage consumption along with the covariance with BMI can be determined from the adjusted regression model. When examining the results, one can see that most of the data in the adjusted column is statistically significant. For every 1 unit increase in the sugar-sweetened beverage consumption being less than 1 drink, the BMI will increase by 0.49 units. Additionally, for every 1 unit increase in the sugar-sweetened beverage consumption being more than 7 drinks, the BMI will increase by 0.47 units. For every 1 unit increase in the participant being female, the BMI will decrease by 0.81. And when looking at the age, for every 1 unit increase, the BMI will increase by 0.02 units. The ethnicity variable was significantly significant. For every 1 unit increase in the participant not being Hispanic, the BMI will decrease by 0.54 units. Additionally, the race variable is statistically significant for blacks and others. For every 1 unit increase in the participant being black, the BMI will increase by 0.98 units. For every 1 unit increase in the participant being other race, the BMI would decrease by 1.42 units. And for every 1 unit increase in the participant being a college graduate, the BMI would decrease by 0.82 units. For every 1 unit increase in the BMI, there is a 2.4 unit increase in developing diabetes. So, in conclusion, the crude linear regression enabled the examination of the linear association between sugar-sweetened beverage consumption and BMI. The data suggests that the sugar-sweetened beverage consumption is associated with BMI. Additionally, the adjusted linear regression enabled examination of the linear association between BMI and sugar-sweetened beverage consumption with other potential confounders. From the adjusted linear regression, the data suggests that the sugar-sweetened beverage consumption, gender, age, ethnicity, race, having a college degree, not being physically active, and having a history of diabetes is associated with BMI. The public health significance of these findings is that sugar sweetened beverage consumption has a potential impact on health among racial, ethical, gender, and low education subgroups. These subgroups are at risk for developing diabetes and obesity. Therefore, the reduction of sugar-sweetened beverages consumption could produce health benefits. In future research, researchers should aim to attain more accurate data on sugar-sweetened beverage consumption without self-reports. Researchers should also test the validity of the data before applying linear regression. Therefore, I will propose a research intervention to prevent obesity through the reduction of sugar-sweetened beverages. The intervention would be framed around the social ecological model. Instead of looking at every level of influence, the intervention will only focus on the policy level of influence. The intervention will aim to change dietary guidelines in schools. This is needed because the National School Lunch Program aligns with the National Dietary Guidelines for Americans, and it promotes the sale of restricted foods with little to no nutrition value. The restriction is only valid during lunch. Sugar-sweetened beverages is still available for purchase during snack periods and at student stores, vending machines, and school events. Therefore, the goal of the intervention is to promote the sale of sugar-sweetened beverages in schools to reduce overall sugar-sweetened beverage consumption among children. This target population would be school-age children, grades K through 12. The objective would be to measure calorie intake and BMI. This could be collected by students submitting self-reports of their calorie intake and BMI over the school year. However, ongoing monitoring will be needed. The policymakers will have to review new dietary guidelines every 5 years, and the schools will have to check randomly throughout the school year for sugar-sweetened beverage distribution. And here are the list of references. Thank you for your time.